welcome to This Explainer. Today, we are completely unpacking the ultimate fabric of reality. I mean, we're talking about dimensions. We're going to climb the ladder of reality, starting from a single infinitely small point and ascending all the way up to the totally mind-bending concept of infinity. Let's just jump right in.
So if I were to ask you right now how many dimensions are there, your brain, which is, biologically wired for our everyday world, would probably immediately jump to the number 3. Up and down, left and right, forwards and backwards. Because, well, that's the limit of what we can physically see and feel on a daily basis.
But what's really interesting is that if you ask theoretical physicists who research string theory and quantum mechanics, you're going to get a completely different answer. They suggest there could be 11 dimensions or even a literally infinite number of them. And honestly, to bridge that massive gap from 3 to infinity, we kind of need to strip away all our preconceptions. Okay, so the absolutely crucial point here is understanding the baseline definition of a dimension. Forget about mystic realms or, sci-fi portals for a second. A dimension simply boils down to degrees of freedom. It's just the exact minimum number of coordinates you need to pinpoint a location within a mathematical space. That's it.
Let's actually build this from the ground up so you can see what I mean. 0 dimensions? That's just a single point with 0 freedom to move. A 1D space is a line, which requires one number. 2D is a flat plane. Think of a map or a game of Battleship, requiring an X and Y coordinate. And then 3D adds depth, requiring a Z coordinate to locate a specific point inside a room.
But here's the catch. Our everyday reality actually demands 4. Think about it. If you want to meet a friend, you need latitude, longitude, and altitude, like, say, the 4th floor on 6th Street South and 5th Street West. But if you don't specify the exact time, which is that 4th dimension, you are still going to completely miss each other.
Now, we need to carefully separate two concepts here before we move on. Albert Einstein gave us the idea of time as a 4th temporal dimension, moving in one direction. But mathematicians, they also deal with a purely mathematical 4th spatial dimension. This is the realm of the tesseract, a shape with 4 actual physical directions of movement.
And look, if trying to picture a 4D physical shape gives you a massive headache, seriously, don't sweat it. Our brains simply aren't built for it. But mathematically, adding a 4th spatial dimension is literally as easy as adding a 4th letter to an algebra equation. As that quote points out, visualizations can lead you astray, but equations are always correct. Working in 4, 5, or even 10 dimensions is exactly the same as working in 3. You just need more paper for the extra coordinates.
And this mathematical freedom is a real game changer. It led to a massive breakthrough in the 1920s. Physicists Theodore Kaluza and Oscar Klein decided to just play around with adding a 5th spatial dimension to Einstein's equations, really just to see what would happen. And amazingly, it perfectly unified gravity and electromagnetism into a single mathematical framework.
Now, naturally, you might be thinking, well, we don't trip over a 5th spatial dimension on our way to work. So to explain why, Kaluza proposed what's known as the cylinder condition. He basically suggested that this extra dimension isn't vast and open. Instead, it wraps and curls tightly around itself, kind of like the circumference of a ridiculously tiny cylinder.
Klein took this idea even further. He calculated that this 5th dimension had to be scrunched down to a bare 10 to the negative 35th power meters. This is a concept physicists call compactification. It's the idea that these extra dimensions exist all around us, right now, but they're compacted so infinitesimally small that our macroscopic world just glosses right over them.
And this brilliant idea didn't just fade away in the 20s. Fast forward to modern theoretical physics, and string theory actually demands 10 dimensions. M theory demands 11. Why? Because fundamental particles are seen as tiny, vibrating strings, and our standard 3D space simply doesn't offer them enough mathematical room to vibrate and create the universe as we know it.
So string theory relies on 6 extra unseen spatial dimensions, and these are curled up into incredibly complex geometric shapes called Calabi-Yau manifolds. What is absolutely mind-blowing about this is that there are over 10 to the power of 200,000 different ways they can fold, and the exact way they fold in our universe, that literally dictates the physical laws and the particles we experience every day.
But wait, we aren't stopping at 11 dimensions. Quantum mechanics throws this entire concept all the way into infinity. To describe a quantum system before it's actually measured, physicists utilize an infinite-dimensional mathematical structure called a Hilbert space. Unlike our physical reality, this represents absolutely every possible state a system could ever take.
And this infinite mathematical space is precisely where sci-fi gets its famous alternate dimension trope. It's driven by the many worlds interpretation, which posits that every time a quantum measurement occurs, reality doesn't just pick one outcome. Instead, it splits. Every decision branches off into an ever-growing tree of parallel universes.
Physicist Max Tegmark actually hits the nail on the head here. He points out that these alternate realities aren't places far away in outer space. Your alternate reality doppelgangers are simply existing on another quantum branch entirely, contained right within this infinite dimensional Hilbert space. They occupy the same space and time, just in a completely different, non-communicating dimension of reality.
So, as you're sitting there right now, anchored in your perfectly familiar 3D spatial world, moving inevitably forward through that fourth dimension of time, I want you to consider the infinite possibilities happening right under your nose. With billions of quantum events occurring in your body every single second, which specific branch of this endless infinite dimensional reality are you actually perceiving right now? It's pretty wild to think about. Thanks for exploring this with me.